Today we are learning logarithms. And what is a logarithm? This is a logarithm, and it is read log base b of a equals x. And a logarithm is just another way of writing exponents, okay? So when it says log b, that is your base of the exponent. X is the exponent, and a is going to be your answer. So this is how you transform a logarithmic expression or equation to an exponential equation. Okay, so let's see how this works in an example. 3 is your base, 2 is the exponent, your answer is 9. So log base 3 of 9 is 2. And how you would write it as an exponential is 3 squared equals 9. Number 2, the base is 6, the exponent is 3. If you multiply 6 by itself 3 times, your answer will be 216. So this is how you write exponents when you're given a log. Let me do a more harder example. Let's do number 5. So this is going to say the base is 4, the exponent is -2. So let's rewrite this. When you have a negative exponent, the rule is make it a positive exponent by putting it in the denominator. This 4 squared is 16. So this becomes 1/16, which is what we have right here. So guys, 4 to the power of -2 is 1/16. That is how it is read. That's what it means. Here, 9 to the power of 3/2 will give you 27. So this is saying 9 to the power of 3/2 is going to be 27. But let's break this down. I can write 9 to the power of 1/2 times 3. Does everyone see how these two are the same thing? You just multiply the numerators. Okay, now remember, whenever you have something raised to the half, this is the same thing as the square root. Okay, so I can rewrite this as the square root of 9 to the power of 3. Well, the square root of 9 is just 3, and 3 to the power of 3 is 27. And that's what they have here. So if I were to write this in exponential form, I'm going to erase my work, or actually I'll write it right here. The answer is 9 to the 3/2 is 27. And I just proved to you how it is 27. Okay, so we just learned how to go from a log to an exponent. Now let's go backwards. We're going to go from an exponent to a log. Now remember, 14 is your base. So that will also be the base for your log. 2 is the exponent that gives you 196. I'll do number 11. Your base is 2. -3 is the exponent that will give you 1/8. And I'll let you guys do number 12. Okay. All right, so a common logarithm. We call the something a log with a base 10 the common logarithm. And it can be written without the base. So oftentimes you'll just see it as log x instead of log base 10 of x. So the common log is 10 and you don't have to write the 10. So now that we know what logarithms mean, let's go ahead and evaluate some. So guys, what exponent does the 7 need in order to give you 49? 2. So that means this is 2. Okay, my base is 3. What does my exponent need to be in order to get 27?
3.
Yep, 3. So that's how we evaluate these logs. Okay? Log, or your base is 12. I need the answer to be 1. So what does the exponent need to be? 0. So log base 12 of 1 is 0. And I'll do one down here. I'll do number 19. The exponent needed to give 1/81st or 81th, however you would say that. Yes, -2. Okay, let's evaluate that over here. 9 to the -2 would be rewritten as 1/9 to the power of 2, which is just 1/81. So that exponent that I needed was a -2. So that is how you evaluate these logarithms. Right, that is the end of our notes. So your answer to this is your answer. Log base 7 of 49 is 2. Log base 9 of 1/81 is -2. Here, log base 12 of 1 is 0. Log base 3 of 27 is 3. Yes.
Yeah.
Number 15. Okay, guys, remember, this is the common log. So what is your base if it's not written? 10.
Oh.
This is the common log. So if you don't have a base, that means your base is just 10. So guys, what does the exponent need to be to get 100? 2. So that means the answer to this problem is 2. Yep, this is the common logarithm. So a logarithm with base 10 is called the common logarithm, and it can be written without the base. So if it doesn't have a base, that means it's the common log. Any more questions? Nice.